Hello. Today we're going to be looking at some more trigonometry things. And first it'll be number of possible angles. So I posted 2 weeks of assignments at once. The first week is going to be the one listed first in the lesson slides, and it's going to be the one that says due on July 11th rather than the 10th. I actually put the due dates in descending order so that they appear in the right order on the screen when I do it 1 week at a time. Now, the idea is finding sides and angles is going to go first. Number of possible angles, here we go. Let's determine the number of values that x could have based on the given information. So it says the sine of x is 0.8736. And we know that could mean that x could be anywhere in the first or second quadrant. So inverse sine of 0.8736 is 0.6087, etc. degrees. And that's going to be one of the angles. And now, to be a little more thorough, let's check the other one. 180 minus that is 119. Adding either of those things to 24 gives you things less than 180. So it could have two possible values. Now, unless there's something that I just have not thought of properly, I don't think there is a way for the answer to be three possible values. But if we run across one where it is the case, then I'll eat my words. Next problem. Same deal. We're going to go ahead and say sine inverse of 0.952. The 72-degree angle, let's do 180 minus that. We get 107, add that to 49, and you still get something less than 180, so both of them fit. This one is where we're going to get a different answer. So inverse sine of 0.4284 is 25 degrees. Perfect. 25 and 48 are less than 180 together. But 180 minus that deal is 154. And now we'll run into something interesting. 154 plus 48 is greater than 180 degrees, as we see here. So that means that only the other angle is going to fit. So only one of them is going to work. Sometimes we'll get 0 if we see something like, boom, 149-degree angle here. So inverse sine of 0.9512. 72 is going to be the smaller of the angles. And if you add that to 149, you're going to get 221, which is greater than 180. So nothing is going to work on that one. So if the smaller angle is bigger than, if the smaller angle is bigger than 180 minus this dude, then we know that we're going to run into that problem. Oh, this one's going to use cosines. So it actually changes up a little bit. Hold on. Inverse cosine of negative 0.9248. So we get 157 degrees. And the other angle that it could be is going to, so for cosines, I don't actually think that we get a 180 minus theta deal. I think we get the other side of that. So we're not actually going to have anything that works well for cosine, because this plus 28 degrees is more than 180. So it's going to be 0. Basically, just follow this along. I trust you to be able to do this. Let's look at the next step, which takes it a little further. Finding angles in a triangle. So this takes a little bit more work. So we have triangle LMN, N is 35, M is 59, and L is 82 degrees. Now what we want from that is, let's just go ahead and draw the triangle. We have 59. We know that the opposite of the lowercase sides are the uppercase angles. So N, oh, whoops, I actually labeled that wrong. N should actually be 35. 59 should live here. And if this is L, that's going to be 82 degrees going here because L is the third side. And each angle is opposite its corresponding side. So what we want to do with this information is, let's first go ahead and use law of cosines to find this side. And I believe that means a squared equals b squared plus c squared minus 2bc cosine A. Why is this not working? And we actually know all of these things. So 59 squared plus 35 squared minus 2 times 59 times 35 cosine of 82 is going to give us the length of L. I'm going to control Z all these things just so that we can see the problem. And we're going to plug that in to a calculator. So we have 59 squared plus 35 squared minus 2 times 35 times 59 times cosine 82. Let me pause real quick. I was just double checking my work there to make sure I was getting law of cosines correct. Didn't want to lead you to the end of the problem and find out we did it wrong. So 4131.21. Now let's go ahead and just wrap parentheses around the whole thing and take the square root to find that side. Dang it. Control X, square root of that. So 64.27. That is going to be our side here. So 64.27. Now we need to use law of sines to show that 64 point whatever over sine 82 is 35 over sine n. So we need to divide this by the sine of 82. And we need to show that that is equal to 35 over sine n. And we can rearrange by simply saying sine n is 35 divided by this whole big mess. So we're going to actually just go ahead and take big parentheses to grab the whole thing, say 35 over that stuff. And that is going to be sine of n. And now what we'll need to do is take the inverse sine of that. It looks big and messy, but it gives us 32.63, which I believe is 33 degrees. And we got it right. So we threw in 33 for the angle. We actually had a pretty exact answer here. So the step-by-step, you can use law of cosines when it has a problem like this in order to find the missing side, and then use law of sines from there to find the missing angle. Now on the other bit, we're going to do finding the angles of the sides of a triangle, my mistake. And here we're going to do something similar that isn't quite the same. So here what we want to do is, let's first label all the angles here. So I'll get rid of this problem, make a new one, and we have, let's plot the angles. The other side of the 42 is going to be 138, which means the third angle in this little triangle is going to be 180 minus those two, so I think 24. Let me make sure I did my math right. Yeah, I did. So the other side of this thing is going to be 90 minus, well, actually, we're going to just know that one. 100. 90 plus 42 adds up to 132. and the rest of that is going to be 48. So what we are going to do now is we want to find the length of WY, and in order to do so, we are first going to have to find the hypotenuse here. That'll be the easiest thing that we can do. And in order to find this hypotenuse, we can use the outside triangle here and use, just a moment, let me double check what I'm looking at here. Law of sines. So we know that 2.7 over sine 24 equals WZ over sine 18, just because of the whole opposites thing. So that shouldn't be too bad for us to do. Let me make sure that I actually did that right. Sine 24, yeah. Okay, yeah. That checks out. So now what we want to do next is simply rearrange to do sine 18 times 2.7 over 24, or sorry, sine 24. So let's just go ahead and plug that into a calculator to find WZ. So 2.7 sine 18 over sine 24. Now we'll actually use parentheses just for the sake of making sure everything is in the right place. That is going to be the side WZ right here. So that's our hypotenuse. And all we need to do is use an inverse trig function to give us the other side here. So if sine of that 48-degree angle, or cosine 42, same difference, is going to give us WY over WZ because of the SOHCAHTOA, then what we can do is say, hold on a second, this is going to be WZ, so hypotenuse times adjacent over hypotenuse gives you adjacent. So that should give us the side WY. And we want it to the nearest hundredth, so let's round 1.5244. That'll be 1.52. That should give us our answer. Sweet, and it does. It's tricky, but it works. We want to find all the angles in the thing, and then we do some inverse trig functions in order to find the last bit. I'll do one more problem with you and then call it for this video. So what we're going to do is find xw to the nearest 10th. So the first thing, again, that we want to do is going to be to find all the angles in this thing. So let's go ahead and move me to the side for a moment. Grab the snipping tool and do exactly that. So we are going to plug in the angles. 90 and 82 leaves an 8-degree angle up here. And that's going to be the red one. Our blue angle up here, 90 and 67 leave a 23-degree angle up here. And we know that the bottom angle, since it's half a straight line, is also a 90-degree angle. So we have a pretty solid start. And what we want to do is find the length of xw to the nearest 10th. The easiest way that we can do that is going to be through a law of sines, I believe. And the way we're going to do that is say this whole angle is 31. I'm going to make that purple because it's red and blue. And so we know that 540 over sine 31 is equal to xz over sine 67. So now let's just go ahead and solve by moving the sign over. So sine 67 times 540 over sine 31. And that answer gives us 965.11. Alrighty. And that's going to be our xz. Now that we have this, we can again do our trig function. So this is going to be our hypotenuse for the left-hand right triangle. And we can find the leg on the bottom by saying this times the cosine of 82, which would give you the question mark side divided by this big long side. So in order by multiplying it by the length xz, it cancels out the denominator and it leaves us with xw, which is 134.3. Note that it says find to the nearest tenth, not hundredth anymore. So this gives us that. We do some law of sine stuff, find the angle, and then just work with it. When y'all are confused, turn to reference sheets, and when you're still confused, send me an email, ask your classmates, look things up on YouTube if you need to. But in the meantime, do your best, and I will see you in class.